Hey, Jared here at Kill Devil Diesel, and today we wanted to show you guys a pretty cool project we've got here from one of our good sled pulling buddies up in Pennsylvania. So this is the Hypermax CGI block you guys might have seen before. We've done a few of them here now. We just finished up one for Brian Jellish. These are a CGI block, which is a compacted graphite iron block, and this is on a very high horsepower, a 2,000 to 3,000 horsepower sled pulling truck. And so the CGI is a much tougher material than the factory gray iron, factory cast iron blocks are. And so this one has been through a few seasons, and they sent it to us to kind of freshen up. And they had what's called fretting. And so the fretting occurs when there's movement here on the mains. And so basically when you have two surfaces, the main cap and the block, that move against each other on a very microscopic level, and that movement actually produces a tremendous amount of heat. And so the block here had a tremendous amount of fretting on it, and it had kind of been repaired once or twice before. This doesn't knock anybody else's work. Again, very high horsepower race car stuff. This is also the Hypermax bed plate, and so these bed plates have a very specific list of specifications on how they're supposed to fit to the block. From the factory, these are individual main caps, and so the really high horsepower sled pulling guys, they'll use these Hypermax bed plates either on the factory blocks or these CGI blocks. Well, the factory main caps, they register into the block where the main cap sits into the saddles of the main register here and here. And so you should have a few thousandths of press fit, and that's kind of what locates the cap side to side. On top of that, this, where the bed plate seals to the oil pan rail here, should have about a thousandths gap, about a 1,000ths gap, and that kind of just gives the silicone somewhere to go. And this had been repaired a couple times. Again, really high horsepower truck, race car, it's going to get rebuilt, frequently. And so during previous rebuilds, it had been welded and been repaired. And what had happened was it was bottoming out on the oil pan rail before it was bottoming out on the mains. And so the main register here, the main webbing, wasn't bottoming out on the main webbing on the block. And so that really allowed it to move around a lot. The other thing is the threads on all of the bolt holes came up all the way to the very bottom of the block here. And so what we did is we recessed those threads, because what we don't want is the tension of the bolts to pull the surface up. We want those two surfaces to be clamped very tightly together. We don't want to pull and distort the main housing surface. And you could see actually in some of the B-roll we'll show here where the area right around here was touching, but the area, the meat of the cap was not touching. So if you look, it's kind of hard to get it to show up on camera perfectly, but if you look right around these bolt holes, you can see that it's shiny right around the edge of the bolt hole. And that's probably because the threads come all the way to the top of the hole. And so if you look at most factory, blocks and stuff, there's at least a few threads, 4 or 5 threads that's not threaded all the way to the end. And the reason they do that is because it'll actually pull that main cap surface up. And so you have really good contact area right around the threads, but then not very good contact around the rest of the cap webbing here. And so I think that's part of what's contributing to the fretting. So what we're going to do, it looks like we're going to double check all this, but it looks like there was some extra threads, sticking up here. Like we can possibly sink these studs a little bit deeper into the block to get more purchase on the stud. And then we can take the top 3 or 4 threads down, just basically plunge cut, to cut the top 3 or 4 threads down here. So it's not pulling those threads here and pulling this surface into the bed plate, because you can kind of see the same here where it had pretty good contact, if I can get it to show up on camera, right around the very edge of the hole, but then massive fretting everywhere else. So we recessed the bolt holes, and then we also added dowel pins, and we do this on our 6064 engines. And what this does is really helps locate and keep everything locked down. The other thing is, this had, instead of having a few thousandths of press fit here, where the main cap area registers into the block, it had a few thousandths of slop to it. So it had about 4, 5, 6 thousandths of slop, where you could actually take that bed plate and rock it back and forth a few thousandths.
This is back of the block. 5 thou.
And so what that meant is there was nothing really holding the mains in place, especially again with all the boost and all the cylinder pressure. And so what we did is we stuck this thing in the oven and got it heated up, and then we TIG welded the main registers here, and then we went back and located off the center of the mains and made sure that we had an even amount of press fit on both sides and machined that back down. So that way we now locate off the dowel pins, and we have press fit here. And then of course we corrected the geometry here. So that way we have our thousandths gap for the silicone and everything bolts up. We had to, of course, reline bore and then reline hone everything back to get the mains square again, because we had to take a few thousandths off of this to deal with the surface that was kind of chewed up. But we got everything repaired. Housing bores are back right where they should be, and this thing's getting ready to go back to Pennsylvania. So it's kind of a cool repair, and it's not often that we get to showcase something at, 2,500, 3,000 horsepower. So we kind of wanted to take a peek on what goes into making an engine like that survive. Anyway, thanks for watching. Have a great day.